All right, so piecewise functions. We're gonna start by graphing our function. You know what that looks like? Go ahead and graph it if you can. If not, watch close. So we have absolute value of x. Sorry, right? That's a piecewise function. Yeah, for real. Okay, here's why. Okay. What happens? What's the slope of this line? -1. What's the y-intercept? 0. Okay. What's the slope of this line? 1, 0. And the y-intercept is 0. Can we write two separate equations for those two lines? Yeah. The question is, where do they stop? There's 0. So this one is greater than or less than 0? And what about x here? Right. We're starting to see all the pieces of our piecewise function. Right? So there's a wall here. That's where they start and stop. That's the hardest part for people here, for some reason, the starting and the stopping point. So if I'm going to write it as a piecewise function, it's got two pieces, right? We have piece 1, piece 2. What's the equation of that one? X. You're hearing negative x. And slope's -1, right? Yeah. -1x plus 0. We don't need to worry about 0. What's the boundary? Okay. And what's the other one going to be? Same function, two pieces, two functions. Okay. So, and again, notice the dividing line. Does this line continue? No, it doesn't, because it's only defined bigger than 0. So this one does not continue in here, it's only defined for less than 0. Okay. You okay with that? All right, let's try a different one. This will be 3 pieces. 1. So now we're going the other direction. We started with the original last time with the other direction this time. So I would put these on the graph first. That's what I do. I'm going to put them in red. So where are my dividing lines? 3. And I actually just put them in the dotted line. And 3, -2. We're good. The 3 sections to get 3 functions. Now there are lots of ways to approach this part. I'll do it a couple different ways for you. What's the graph of this one? Say what? Bundles? What is the graph of that? Y equals 1. That would be y equals 1. I have ignored the boundaries, right? I've ignored the boundaries. So if you need to just graph it, that's fine. What do I need to erase? And then erase above. Hopefully this works. Now, on that line there, I need a solid dot. Why do I need a solid dot? Please. Go ahead. What?
Anything less, or yeah, anything less than an equal.
Or equal. The equal gives us a solid dot, right? So it's less than or equal to, below it. Does that work for you? Yeah. The other method, let's do the rest of this. 2 plus x. Y-intercept is 2. So we have y equals x plus 2. You can graph that out again. So 2, and then the slope is 1. If it works for you, you can draw the whole line. And we're letting to erase. Alyssa, do you know? What do I need to erase?
About 3.
Okay. And? Right. Okay, now do we need hollow or solid dots? Hollow. Hollow? I'll say solid. So you can see it starting to come up. I know you can graph each of these lines individually. I've seen it individually. But you just got to figure out where to cut it off. Then we got the last one. Some other
and 2x. So the y-intercept is 0 up 2 over 1. If you don't want to have to erase, okay, I started with the y-intercept of 0, and I just tracked my way up to where it hit the wall and went beyond it because it's above 3. That's the other way to do it. Hollow? Oh, it is. Make that a hollow dot. And then you have your 3 pieces graph. Kind of hard to do the erase part if you're working in pen. Okay. So pencils are good for the erase part. You can do them in colors, that helps a lot. For linear functions, you can also get the locations of these at those values. So what is the value of that at -2? If that would generate the point -2, 1, right? That's there, and you can draw your graph. You can also do this one. -2, what does that give us? 0. So you can plot that point. You can then plot this point at 3, 5, and connect the dots. It's linear. We can go elementary on ourselves, like connect the dots. That one is a touch different. Always different. 3, 6, and slope is 2. So get 3, 6, and then go up 2 over 1. And that's why. Lots of ways to section these out. Cool? Is it a little clearer than mud now? A little bit? A little bit? What? That's good, Steve. Sewage water, okay, so we'll have to mud the sewage water. That's fantastic. And a little activity for us to do. So hopefully maybe that'll help. Yeah, this is a big, thick packet. We're not going to get through all that. Probably won't get through all ever, but. Yeah, it's from Hawaii. Yeah. I don't know how far we're going to get in this. Let me write your homework down, but you can shut the video off. It's 1.8. Sorry, 1.7. I'm really on a roll today. 1.7 and 1, 8 through 6, 8 through 12, 31 through 37. Yep.